Hello and welcome back to 4.9 lesson. I think that's how we did it. It's been so long. Okay. Examine properties of trigonometric expressions. What properties of expressions of trigonometric ratios? That means basically what can they do for us? I mean, what do they do? What are they actually? Property is like a feature. So what are their features? What observations can I make about the relationships between trigonometric ratios of the two different reference angles at a right triangle? So basically that means if I'm using this as the reference angle, that's the opposite, this the adjacent. But if I switch to this angle, now that's the opposite, this the adjacent. So how does switching ends work out? This is always the hypotenuse, which makes it interesting, right? How do the properties of right triangle influence algebraic statements involving trigonometric expressions? All right, that's the fun part, which we'll jump into right here. Because basically, how do their features, their properties, help us with algebra to find stuff? Because algebra, finds the missing piece, finds the variable. So here's a triangle with some missing sides. We can't use Pythagoras because to use Pythagoras you need two sides. A squared plus b squared equals c squared. Well, we only have the c squared. We don't have the a or the b. So there's a bunch of possibilities. There's a bunch of different right triangles that could have this hypotenuse. But these sides would be different, which we don't know what they are. So, but wait, it's locked in at 30 degrees. So we know the ratio of a right triangle with 30 degrees. We know the ratios of all the sides. They're known things. They were measured thousands of years ago. People wrote them down. And nowadays, we grab our calculator to look it up. Let's see. I have to go into portrait mode. Nope, I have a little drop down. Here we go. So if I want to know what the ratio is of like this side over here to the 8, that is from this reference angle. This is the opposite side from this reference angle. This is always the hypotenuse because it's opposite the 90. So I write down SOHCAHTOA. Opposite hypotenuse. I'm going to move this out of the way so the lighting's better. Give me 1 second. SOHCAHTOA. There's no H in TOA, by the way. Just 3 letters each. I got an opposite and a hypotenuse. There's hypotenuse, but not an opposite. There's hypotenuse and the opposite is sine. Okay, now I'll bring the calculator back in here. What is the sine ratio for 30 degrees? I think I am in here. See this deg? I need to hit this deg. There we go. So in degrees, 30 degrees, the sine ratio is known for thousands of years. It's known to be half. So one of the few trig ratios that's a simple fraction, 1/2, instead of like a crazy decimal. And that's why they're using it right now. In fact, look, they know that the sine ratio for 30 degrees angle is always 0.5. The ratio of the opposite to the hypotenuse is always half. If this is 30 degrees, this is always half of that. So we can already tell it's going to be 4, because that's an 8. But let's just write it out real quick. As the sine of 30 degrees equals 1/2 equals x, we don't know the side, the unknown x, over 8. And now we can use algebra. This is times 4. So this has to be times 4 to keep the fraction equal. And therefore x equals 4. You can also use old school algebra multiply both sides by 8 to clear out the denominator. And it's 8 over 2. 1 times 8 is 8 on top. 2 times 1, because the 8 over 1 is 8, and we're multiplying by 8, right? It's 4, so 4 equals x. Yay. Okay, we need the other side, though. Oh, now we can use Pythagoras. E squared. B squared equals 64 minus 16, 54, 48. Awkward. Yeah, I think that's right. Approximately 6.9, because if it was 49, it would just be 7, so something like that. The square root of 49 is 7, so the square root of 48 is slightly smaller than 7. You can find the values of trigonometric ratios on a scientific or graphing calculator. Find the cosine and the sine ratios for 50 degrees on a calculator. Come on back in here, dude. Make sure you're in degrees. And clear sine 50 points. See, this is not a simple fraction like 1/2. It's 0.766044444. That's cool. 311, 8, 9. And it actually goes on like pi forever. The ratio can never be exactified with our numbers. So we'll just make it approximately 0.77. And I just screwed up because that was the sine and they wanted the cosine. If you want to prevent those sorts of errors, grab your own calculator. Don't trust the teacher. Cosine 50.64. This is 0.77. I'll zoom in a little bit more. Use the information to find both of the missing sides of the right triangle. All right, let's do the, well, they have the cosine listed first, so let's do the cosine. This is adjacent to the 50. We don't know what it is, but we do know that the cosine ratio of 50 degrees equals 0.6, or is approximately 0.64. But we also know that it has to be adjacent over hypotenuse. Cosine is adjacent over hypotenuse. Adjacent to 50 is the x, we don't know, but we do know the hypotenuse is 12. How could I solve this with algebra? Now, you don't actually have to write this down. You just need to write down the approximate value of the cosine of 50 degrees. We know that the cosine ratio for this corner is 0.64, but we also know it's a ratio of this side to that side. The only reason why we know it's 0.64 is because someone calculated it with a ruler hundreds of years ago and put it, and then the calculator actually has some methods, but whatever. Let's just use the known fact compared to our specific case to figure out our specific piece. Now, even though we have the approximation, here it's exactly right. So if I just hit times, oops, that's not good. Backspace. If I just hit times 12, it'll give me a more exact answer that I can round this to 7.7. That makes me happy. Still approximate. All right, let's do the sine. So opposite over hypotenuse. Should be an H. Oops. So sine is the opposite of hypotenuse. The sine of 50 degrees is 0.77, and that should be equal to this unknown, which we call this y, b, let's call it b over 12. And this is why it's really fun to know the hypotenuse, because you can clear the denominator. Since the hypotenuse is always in the denominator, if you know it, you just multiply by it to clear it out. Multiply by it on the other side. And once again, we could use this approximation, but we can also look it up exactly again, sine of 50, and even hit enter. There is the exact, see, I rounded it to 0.77, but there's the real value, and then multiply by 12 and get a more exact 9.19. Approximately. Oh man, approximately. So there's our two, it said, find both of the missing sides. There it is. So it involves knowing the ratio parts, the known number. You need to know at least one side, right? Using the known side and the other parts, set up a ratio, using a calculator to look up the known value as a decimal, and then using algebra to find the missing piece. Next page. Okay. Okay. Record all of your work. Record all of your work so someone else can follow it. So they want us to find this adjacent side right here. Let's call it A. Now, we know that we call the cosine ratio the adjacent over the hypotenuse. Cosine is adjacent over hypotenuse. That's supposed to be an H. And in this case, we don't know A, but we do know the 10. But let's find the cosine of 75. Help us out, oh giant computer. 0.25, 0.26. So now we have an algebra problem. We know the specific parts here are the A and the 10, but we know that they need to equal 0.26 for any right triangle in the world with the 75 degrees. This ratio is going to be approximately 0.26. This is expressed as a decimal. We have it expressed here as a fraction with the missing piece. Let's algebraify this. Times 10 times 10. A equals 2.6. Ooh. They want us to find the opposite. Let's call it B. We have the adjacent. I write down SOHCAHTOA. Okay, so this is the op. This is the adjacent. There's opposite, but the hypotenuse. There's the adjacent, but the hypotenuse. There's the opposite and the adjacent. That's the one I want. I want to know, oh magic computer, what is the tan of 35 degrees? .7, almost exactly. But in the specific case, I know that the tangent here is the B over the 10. Let's use some algebra. B equals 7. Find the hypotenuse. Okay, this is a little bit tricky, but we'll still get it. We have this ratio, which is the opposite over hypotenuse. That is the opposite in hypotenuse. That would be the sine ratio. So sine a ratio of 48 degrees, please. Look it up. 0.74. Oh, 0.74. Really bad at approximate. But I also know that 0.74 approximately must be equal to the ratio of 8 over h in this specific triangle. Basically, the calculator finds it for every finds the ratio for every triangle. Then you take the specific pieces from your specific triangle that have to equal this 0.74 as a fraction. Here's my fraction, but I'm missing a piece of it. Okay, but now because the missing piece is in the denominator instead of the numerator, we have to do slightly different work. Up here, it was easy. We knew what the denominator is, so we cleared it out. We figured out the numerator. Now we don't know what the denominator is. We can still clear it out, times h on both sides, but now there's going to be an extra step, because now it's 0.74h. My pencil is really glary. I'm recording at home. I don't usually do that. And these are cleared out, and this is 8. But now there's an extra step. Divided by 0.74. And then you have to do 8 divided by 0.74. Oops. 10.8. H equals 10.8 approximately. Alright, go ahead, keep going. Set up some more ratios, and your goal is to get through problem 7. Get through problem 7, and then we'll continue with problem 8 tomorrow. Bye.